Okay, so we are discussing design of classes with data members and instant methods in VB.NET. This is me from Rose State College. And basically, we mentioned that if you have classes only with the static methods, you might be calling all these methods, and you are hoping that you will be passing the same data member, same data value each time. But notice there is a duplication of data supply here. We have to supply the same data 4 times. That could be a problem because if we are doing it in different parts of code, at one place the value may be right, other place value may be wrong. So we want to remove this duplication of data supply by making something like this as a part of the class or class data member. And the way it is done is that if this was my square class earlier, and you have done squares and cubes the same way, then here the value d was being passed, and here value d was passed again, and if you have 4 other methods, value d might be passed again. Well, we take it out of here and make it as a member of the class like this. And I'm going to show you that last time we had the square root in cubes class where a was a data member, a was a data member, a was a data member, as many times as we have number of methods. Well, we don't want to do that. We want to make it as a class member. So here's my second project, and let me create a class there called squares and cubes 2. So new, okay, I haven't done the project yet, so do the project. Okay, still need the console application. That part is not a problem. Squares and cubes 2. Okay, and I'll delete module in a minute, but let me add a class here. Add new item. So my class will be squares and cubes 2. Add that. Okay, remove the module, delete. Okay, so we said we want to make A, which was the side, as data member, and we still want to work through the diagrammer. So view class diagram, which showed all these things, but really all I need is one of them. So I don't need that, don't need that, don't need that, just need this one here. Expand that, go to full signature, which won't affect anything right now, but later on it will. So that's that. So we want to add a data member here. Data members are called fields. So if you see at the bottom here, you have methods, properties, and fields. So we add a field. So since we call it A, which is the side, we can give a description in a second. Type will be double type. We want to make it private. Private means that rest of the world can't see it. Okay, and what that means, we'll explain that in a second. But let's give it a summary. This is one side of cube or square. Okay, and if I go to my code window, to go to code, we can just double click here, and notice that put that as data member. Description is one side of cube or square. Okay. Private means that unless we allow through some piece of code in this class access to this, it will be hidden. And there is a good reason for that. Let's say you have some data sitting in the database, and you access that through and make it a member of a class or something. Well, it's not a good idea for anybody to be able to see that data unless you want to provide access to that. So we pretty much follow the same principle as in the database. Like, nobody can actually look at the database unless you are providing access through some access mechanism. So declaring data members as private is the access control mechanism, okay, which we do in all languages, whether it's C++, C Sharp, Visual Basic. We hide our data so that other people don't have access to it unless we tell them how to access it. And we can tell them how to access it when we provide them a method to access it or interface to access it, okay? So that's the reason for making the data member private. The other thing was, in the previous case, we had density also. Did we do density last time? Somehow I don't see that in the signature. Oh yeah, it is right here. So the second thing we do is we make density as the data member. So I can go to my diagrammer right here and add the second data member. So to add second data member, all you have to do is click here on the add field. Can everybody see that? Add field. And type density. And density also need not be whole number. So we make it double also private. And here we say density of cube material. Whatever cube is made of, that's the density of that. And as soon as you do that, my second data member came in, and that is shown also right here, okay? You can add constants to the class. I'm going to skip that for now. I can show that to you later. Like, you can add constants like that cube has 12 sides, 12 edges. You can add constants like that. Or square has 4 edges, 4 sides. So that can be added. Actually, that's not done. It's not too hard. I think I should do at least one of them. So add, let's say, okay, all caps for this constants. Number of sides in square. That will be integer, private. There may be a way to declare that as a constant here somewhere. Constant kind. Okay. Const. So if property value is not valid. Okay. Well, let's make it read only then. Cancel. Read only. Yeah. Okay. So let's see. Shared is false. That's fine. We can make it shared too, actually, because it's not going to change. So go to code window. Shared read only. Read only means that you cannot change the value. Okay, and I can put a value here equals 4, and that'll work. Okay. Read only means you can only read it. You can't change it. And shared means static. That means that for all instances of this class, it will always have the same value. Okay. So we fixed it in value basically. So let's do that for the number of edges for the cube also. So where am I? Okay, right here. So add number of sides. For cube, edges is probably a better word. Edges, cube. Integer also, private. I wonder if there's a way for me to give a value. Oh, initial value. Yeah, I can put the initial value right here. See? So that's also read only. Initial value 12. There you go. And I can put a description. Number of sides in a square. Oops, sorry. Take off the cap lock. There you go. Okay, so if I go to my code now, it put in the value automatically. So that's how you can design things that are constant. Okay, things that are constant should have all uppercase letters. It's easier to recognize them. Okay. Okay, so far so good. Now you will say that, okay, I made everything private. How would I provide access to that? How can I even put the initial values? For that we use something called a constructor. Okay, most people in this class are familiar with the constructors. Constructor construct your object the very first time. Uses the word new. Okay, and generally it's a good idea to provide two constructors. One that puts the data members to some default value. Okay, so if you want to provide a constructor, we add something in the method. I think just called it a new, and this will be a public, because if constructor cannot be seen by rest of the world, then it's useless. So summary would be default constructor. Doesn't really need any code, but if you put the code just for our purpose, it doesn't hurt anything. So it has the sub new. Constructors are in .NET, at least in VB, they're called sub procedures. They are not functions. They don't return anything. Okay, they create an object, but they don't really return anything. So here, if you wanted to, you could put A as 0 and density as 0, although you don't have to do it, because automatically this is already initialized to 0 and this is already initialized to 0. Okay, but if you just wanted to be sure, you can just set A equal to 0.0 and density equal to 0.0. Okay, so all of a sudden there's something interesting. Although A is private for rest of the world, it is still visible inside all the methods in that class. Okay? So all the data members at the class level are visible in all the methods inside that class. Is that concept clear? People who don't have much practice with classes, is that clear? Joseph, clear? Say something so you will get recorded. Yes, no, maybe. Data members that are declared in the class are visible in all the methods. Okay? So just that's all you remember. Otherwise I would have had a red line here, right? And here. I would have had a red line here. If they're not visible here, I would have a red line there. Okay? So that's all I want to say. It's hidden to the rest of the world, but visible to all the methods that we're going to put it here. All right? So if I create a object now, it'll give me side of 0 and density of 0.0, which is not very useful. So I need another constructor, which is called an explicit constructor. So I go here again, and this time I put again the word new, public, but this time I add some data members to it. So let's say edge, which will be double type, does not have to have access. You can do by value or by reference. We're not going to worry about that right now. Everything should be by value, because that doesn't really change things too much. So this is the value of side, or did we have A passed to constructor. That's one thing. And then we need to add the density. Den, I'll just call it den, double type also, no, sorry. Okay, value of density passed to the constructor. Done. So if you see the code for that is right here. Okay. And actually I forgot one thing. Let's do that again. Here, explicit constructor. Explicit constructor. Okay, so what explicit constructor is supposed to do is that user will pass a value of edge and value of density, and this class level data should be initialized to that. So the body of the constructor will say A equals edge. That's first assignment, and density equals den. That's the second assignment. So this kind of constructor allows user to create a squares and cubes instance with the edge or side that they want and with the density they want. Okay? And don't forget that since these two are visible in all the methods, if I write an area method now, those two are visible. I can use them inside that. Okay? All right, so let's write the area method. Okay, so let's do that. So we are done with the constructors. Add a method. So what name did we use? We're going to keep the same name. Get area of square. Okay, so add the method. Get area of square. Okay, I already have this in the class. Do I need to pass an argument here? Hello? Eric? Do we need to pass an argument to get area now? It's already part of the class, right? That's it. We can just use it from there. Don't need to pass, although we need to. This will be a function, so it's going to return a type. So it's going to return a double type because it's a function. And let's see, function we shared is false, correct? Okay, so that will do it. No, okay. Type was what? Type double. Anytime you put a type, then it's fine. I can put a summary here or summary there. Return, excuse me, returns the area of square of side A stored as class data member. Okay, done. So now I can put the code for this one. Notice it's already coded as a function. So return what code will be there for the area of the square whose side is stored right here. Tell me, help me. What should I return here? A multiplied by A. Edge is A inside. Edge was the argument to the constructor, of course. But the class member is A. So don't forget the difference. Edge was the constructor argument, but actually class data is A. So return that. Okay. So now let's see if this thing even works. Okay. So we're going to add another class. We delete our module. So right click, add new item, class, but we'll call it main class because it's going to have main method. And then we add public shared sub main with uppercase. And so first we call the explicit constructor to create an object. So that would be very simply, I say dim let's say sq1 equal to new squares and cubes. Here's my explicit constructor. If I put parentheses, it will tell me that you have two of them. This is the default, takes no arguments. If I click on this arrow, it tells me there's another one and tells me what to pass. So let's say we pass edge size 2.1 and the density, let's say 3.1. Okay. So at this line, what it did was it set this value through this constructor to 2.1 and the density through the constructor to 3.1. Okay. In a minute I can show it to you through the debugging process also that it's actually that. Okay. But let's do just a little bit more here. And actually I have to change the project property, otherwise it won't work. Okay, so startup object is not that, but it should be main class. Okay, so that's done. Then since I have a method called get area of square, I can call that and actually get the area of the square. So we'll print that console dot write line, and I'll use the format string version. Area of the square of side 2.1. Since I hard coded, I have to hard code it here. Equals argument 0 colon 0.00 to format it to 2 decimal place. Those of you who didn't know that, you can learn it now. And now I call the method sq1 dot get area of square. You can call the method right there, and it should give me basically square of 2.1. So let's compile and run it, and square of 2.1 will be something like 4.41. Okay. So some of you might say, how did that happen? Well, we can actually walk through the code using a debugging process. To invoke debugging process, just press F10 after your program is compiled. Okay.